On y va. Thank you. Good afternoon, everyone. I'm Jérémy Picot-Clémente, and I'm pleased to welcome you for this EPIC online meeting on laser rangefinders and sports optics. So most of you already know EPIC, but for those who doesn't know us yet, EPIC is a lasers industry association with more than 750 members working in the field of photonics. We try to act as a catalyzer for the ecosystem by maintaining a strong network interaction between our members, by organizing physical and online events, publishing markets and technology reports, organizing technical workshops, and with a lot of other activities you can find on our website. In the last 2 years, we organized more than 100 OTM, and this is the calendar until the end of June 2022. Soon we will add the event until the end of the year. We try to organize one EPIC OTM per week and cover all the photonics-related technologies, laser sensors, PICs, optics and micro-optics, imaging, and else, and also markets, quantum, environment, agri-food, defense and space, automotive, medical, and so on and so forth. So that's why you could find always an event related to your activities and your market. You can check on our website to get more information if you want. Before to step into the technical discussion, let me introduce you my colleague Antonio Raspa, who helped me in the preparation of this meeting, and who will drive with me the discussion of this afternoon. And we would like also to introduce you the EPIC team. Antonio?
Yes, thank you so much. So it's really a pleasure to introduce all the EPIC team that makes these events possible. We have colleagues dealing with technology, as well other colleagues of the team that is preparing our marketing reports, preparing the events, and supporting to make all the activities that we do for the development of the photonics ecosystem. So we support all of this ecosystem with mentorship activities, with supporting searching for profiles through the website Photonics, Jobs in Photonics, as well with investment and other players on this. Please, the next one.
So thank you, Antonio. So this OTM is sponsored by 4 companies, and thank you. Acktar Advanced Coatings, which is a world-leading company in light absorption materials and coatings that provide solutions for the suppression of straight light in visible sphere and wear wavelengths. We have also OFS, which provides fiber optic solution to several areas, including communication, medicine, industrial automation, sensing, and else. And we'll see during this time how optical fiber solution can also be used for sports application. We have Edmund Optics, which is also a sponsor of today's OTM. Edmund Optics is a leading global provider of optical components, imaging products and assemblies. They offer many standard components such as lenses, prisms, filters, custom materials for a lot of application. And last but not least, Modulight, as well-known companies which design and manufacture laser solutions for medicine application initially, but they are actually also working on several laser applications as laser finding systems, LiDAR, etc. So if you want to get in touch with any of the participants today, feel free to send us an email and we will introduce you. You can find our email contact so here, and you can also add us on LinkedIn. So today we'll discuss about how photonics is involved in sports activities and markets. We'll see really interesting use cases also, and we'll try to bring the discussion to another level with our great speakers and participants who cover an important part of the supply chain of this field, from the component fabrication to the application. We'll have 5 speakers today: Gernot from SCHOTT, Angelo from Tecnottica Consonni, Dr. Christian Brock from Optocraft, Dr. Romain Guyard with a use case in optical fibers sensing for sales races. And to close this event, we'll have a presentation of Active Look and augmented reality glasses for outdoor sports, presented by Xavier Bonjour from MicroLED. We'll also have 2 one-slide presentations from Marina Postnikova from Phasics and Jessica Van Eck, who will present the European Freeform Optics pilot line and the current open call. So, Antonio, can you introduce the supply chain of today's OTM, please?
Yes, sir. As said, here we have a very interesting spectrum of participants. We will have among our registered people end user from consumer electronics, security and defense, as well sport binoculars and healthcare. We have also the presence of system integrators and all the other players like laser manufacturers, metrology system provider, materials and coatings, optics and micro-optics, and what else. This is really the spirit of this meeting, to bring all together the value chain. And if somebody is not in this slide, don't be upset, because this slide is representing the people registered for this meeting. You are all welcome to join our meeting and discuss with us. So we can proceed to the discussion.
Thanks, Antonio. Now let's start with our first speaker, Gernot Weber, who is a global product manager for IR materials, as well as the responsible of the global active laser glass business at SCHOTT. So Gernot, please, the floor is yours. You can share.
Thanks very much, Jérémy. Let me just share my screen, and then we start. So can everybody see my screen?
Yeah.
Okay, thanks very much for giving me the possibility and be the icebreaker today for the presentation here. I'm Jérémy. Thanks again for the introduction. What I would like to do is I would like to give you a little bit an overview about SCHOTT. What is SCHOTT all about, so that you have an idea about who you are talking to. But I guess most of you know SCHOTT. And then I want to go into a specific problem when it comes to laser rangefinders, and where are we coming from, and what might be the chance for sports optics to use, in this case, our material. So let's start. SCHOTT is a relatively big company. In the last financial year was pretty successful. We made about 2.5 billion in revenue and about 550 million in EBIT. We employ more than 17,000 people, and we are in more than 34 countries of the world. So what is SCHOTT doing? And when you look at SCHOTT, you see we are organized in 3 segments. There's the one segment. Let me see if I can put my laser pointer. Yeah. There's the one segment here, home appliance, and I guess a lot of you know this. We have the ceramic cooking tops and the flat glass for oven windows. Then we have precision materials, where we have pharmaceutical systems, everything that has to do with vials, and we provided a lot of the little vials for the vaccination. We produce glass tubing, and here electronic packaging is one famous example. Is here the airbag ignition parts. This is a little tiny part which ignites the airbag when you have a crash, and we have about 80% of the market share here. And here now, optical industry, this is where I am located. It's in advanced optics. This is everything which has to do with glass materials when it comes to optics, when it goes into astronomy, space, augmented reality. I will jump in there later. And then our colleagues from lighting and imaging, what it's about when it comes to glass fibers, everything what has to do with glass fibers. So pretty short, what are we supplying at the advanced optics? We are in metrology, so we make the glasses for measurement systems. We're in consumer electronics, and here I show you here these little tiny filters which are in front of handy cameras. We are in the semiconductor industry, where we deliver special materials for wafer steppers. We have one of our newest fields is augmented reality, where we deliver the glass for the glass for the glasses. We're in automotive when it comes to light application, and here is filter glass. And we have a really big section when it comes to astronomy and space. Here we have our famous material, silver. We are located all over the world. Our headquarters, as I mentioned, here is in Mainz. Then we have a center of excellence for coding in Switzerland, in components. Then we have a processing of raw material in Malaysia, and here in Asia, we are with a wafer processing. And I recently relocated to SCHOTT North America, where we have the melting and the processing of laser glass and IR material, as well as there's the headquarters for the R&D of whole America for SCHOTT. So let's step into the technology. And I was asking myself, so normally I have to admit we are not into sports optics and we are not into the commercial market when it I asked myself the question, so what is actually the limiting factor? Why are we not in there that much? And what is there the problem when you look at commercial available laser rangefinder? And what I saw and what I find out is that the most important point is here that you reach the laser safety class 1, so that nobody gets hurt with your laser rangefinder, maybe when you're on a golf course or maybe when you are hunting, that nobody got hit by your laser beam and has some problems with the eyes. And therefore there are different laser safety classes, and you have to reach a certain level to be safe. So when we look at a principal work of a laser rangefinder, and I know there are guys out there who have much more experience about this laser rangefinder and how to build it. But here, when you look at it, it's most commonly laser rangefinder, they operate in the wavelengths of 905 nanometer, which is not visible for the human eye. They use PLD, a pulsed laser diode, which is sending out laser pulses. And they use the time of flight measurement to know, okay, how far is the target away. You have a receiver mostly made out of silicon, which has a high density at 900 nanometers. And here now the point is coming when you are working with the 900 nanometer laser, the most power you can apply here is about 1 milliwatt. And then you are still in class 1. And between 1.2 microns and about 0.7 microns, the corona is partly transparent. And when the laser beam gets into your eye, it can damage the retina. So that's your problem. So in order to reach higher measurement range, and you need more power that you can send out the laser beam further away, you need a better concentrated laser beam, and then you can measure distance away or farther away. So this laser class number 1 is what I figured out here, one of the biggest area where the problem is. And another point is that then the laser beam is spread out really wide, and then it's really hard to recognize your actually target. And I made an example here when it's the pin on the green that you have problems. To make it a little bit more visible, I found this here, and here you see exactly when you see the 900 nanometer wavebands. So you have to stay at 1 milliwatt here, and that is the laser classes of the beam. And when you jump into a different wavelength, you can increase your laser power 10 times. And now, because SCHOTT is a glass company, what can you use? You can use a so-called laser class. And then you are here in the 1.5 micron range for your laser rangefinder. So what do you get there is like when you can increase the power, you can get more range, you can get more precision, and you can do this with very small parts up to 9,000 meters. And when you increase then this everything, it can go up to 20 kilometers or even further than 20 kilometers. So what can we do, or what can SCHOTT do to help the industry to go further and to go for longer distance, even for sports optics and in the sports area. It is, you can use an ytterbium doped laser class as a gain medium, not a crystal, what is usually used here in a laser diode. You can use here a glass. And here you have the possibility to play around with the doping levels, which means you can adjust your laser class to the perfect needs you have. And let me just give a little brief overview about how such a laser works in very theory. Is you have your laser gain medium. This would be here your laser class. You have a reflector and output coupler. Then you have a pumping source. So you pump this class and then you generate very easily this laser beam. So how is this done? How are you usually pump this laser class? So you can use a diode, this laser class, or you can use a flashlight. And usually these laser materials we provide, laser classes are pumped at a wavelength at about 975 nanometers. So because there's the absorption of the ytterbium ions. So, and what happens then? So essentially what you do is like you do a co-doping. And here you can play now with ytterbium and erbium, and they play together. So the ytterbium is likes to, let's say, laser, and with the erbium and the ytterbium, you can bring this up. So you can pump more energy into your gain medium, which means you get, when you have a shorter, little tinier piece, you can get more energy in, or better energy in, and that means you can get more energy out. So then there's a little problem when you use the normal silica class. There you can put in the dopings, but then at a certain point you have the problem, it's called clustering, and then you don't have a homogeneous distribution of your ions and of the material, and then you get problems in your gain medium, pretty easy speaking. What you can do then is, you, instead of using silica glass, you can go up to a phosphor glass, and then you can even put more ions in. So get more, have more possibility to pump more and get more energy out of the material. And our existing customers are doing this. And here you see a little tiny picture, or another tiny picture. You see how tiny are these rods are, which are used in laser rangefinder application. And what we are doing is we make these little tiny rods or blocks or whatever you see. We are able to coat them too. We are able to manufacture them, and even we are able to test them. So, generally speaking, a laser class could be an alternative for a crystal because of its eye-safe laser class range, eye-safe laser class capabilities. It has the possibility of being very, very small, very, very low power consumption, and you can build very, very small. And this brings me to my last slide. Here, this active laser class can be not only used in laser applications and in laser rangefinder applications, it is used in skin treatment. It is here, as I said, here in laser rangefinder. We are more present in the defense, and I hope to bring this over into the commercial business too. And we are in commercial business when it comes to satellite communications, and hopefully in laser rangefinders for sports optic too, and for hunting. So again, I said we have the eye-safe laser class, the material. You have the possibility to put more erbium and ytterbium into a crystal, more laser output, higher increase of the transfer of pumping energy. You can make it really, really small. You can even, when you make the glass really big, you can go up to 20 kilometers and more. You have a high beam quality when you use glass, and with a high homogeneity in the glass. You can pump it certain ways with a diode or a flashlight. Then you need a little bit of chromium inside your glass. And this is what I would like to show the capabilities of SCHOTT, and that laser glass could be a possibility to use in sports optics too. And I mentioned before, we are happy to get your questions, to get your requests. And Jérémy, that's all. Thank you very much for having me here and giving me the possibility to introduce laser glass to the community. Thank you.
Thank you very much, Gernot. It was really interesting. Oh, well, already a question from Patrice from Interaction. Patrice, please.
Yes, really interesting talk. Thank you very much. I wondered if it's possible to use the same principle to get the amplification. So use a doped glass to amplify laser source, another laser source, than a pump. Thanks.
That's a good question. But when you use laser glass again to pump the source, you can do this. This usually is being done when you have really big, a high power laser, like when you want to get a lot of energy into it, like in the NIF, National Ignition Facility. There, they're going to use lasers to pump the glass, the laser glass, to get more energy out. Here in this, let's say, more little application, it is more sufficient to use diodes or flash lamps.
Okay, thank you.
Thank you for the question. So do we have other question from the participants? Yeah, we have a question from Frank Lexer from Zravowski. Please, Frank.
You have to unmute.
Yeah. You're muted.
Now it's working. Can you hear me?
Yes.
Oh, sorry. The picture was gone, so I couldn't unmute. Thanks, Mr. Weber, for the presentation. My question would be, if as we are in the consumer electronics market, what about the costs involved and the outdoor energy consumption? Could you give us a brief overview how this would affect the overall system? If these two parameters.
Yes. What the cost for the laser glass is really particularly small. The cost is in the laser cavity later on. So where do you put your tiny piece in, and how do you get the laser beam out? We know, and that with laser glass you're more at the upper level, because you can reach further distance, and in defense applications we are the material of choice, because you can go further and you have the eye safe laser. Yes, it will be more expensive, and it wouldn't be a laser rangefinder in the range of below, let's say, 500 euros or below 1,000 euros. It would be, we have to be honest, it would be in a premium sector there, where somebody would say, hey, I want to really have a laser rangefinder where I can do 1,000 meters or 1,500 or 2,000 meters for hunting purposes too, where you can say long range shooting, etc. Then this would be the material of choice. And the low end, and I looked at the internet, when it comes to $150, $200, $299, I don't think that it would be possible to use the glass there.
Thanks. And the energy consumption, that would be the second question.
It's very low, the energy consumption. They usually, what I know from our defense customer, they run on two batteries, about two 1.5 micro batteries, about 8 hours to 10 hours.
Thanks very much.
Yeah.
Thank you, Frank, for your question. Do you have other question from participant? No, on YouTube maybe, no. Okay, so let's move on. Thank you very much, Gernot.
Thank you very much.
Thank you very much for your presentation. So let's move on. Our second speaker is Marina Postnikova from PASIX. It's a one-slide presentation, so a really short presentation. So Marina, please, you can share your screen and start if you're ready.
So, hello, everyone. You can see my screen well?
Yes. Yes.
Okay. So I click the other. So as Jeremy present, I'm Marina. I'm from a technical science engineer from the physics. And I'm going to introduce you to our company and what we can do for sport optics. So in general, the physics provides a high resolution wavefront sensor solution, and all our product is based on the one technology, quadri wave lateral sharing interferometry. So for the sport optics, for instance, like hunting optics is represented by reflexoscope and binocular. It's a complex optical system with the specific technical requirements. And to characterize such optics, it's required precise, complete, and reproducible measurement. So the physics provide a different solution for optical quality control, and as well it provides all level of integration from single wavefront sensor to complete system. For instance, modular metrology system or wavefront test station like Kaleo multi-wave. For example, you can see the schematic representation, the test station and the reference mirror. And in between, could place the sport optics need to be characterized. For example, the binocular. You can see the intensity map image of the binocular, and the binocular placed in the way that it could slide automated. So it provides the measurement on the left, or for example, you can see here, or on the right ocular, which gives the flexibility of measurement. Also, such measurement is operator independent. For instance, this measurement was performed by 3 different persons. And as outcomes parameters of wavefront measurement, you receive phase map, of course, of the left and right ocular, as well multi-wave MTF, sorry, measurement, and main aberration represented by Zernike coefficient. And as I mentioned above, our wavefront sensing solution provides versatility in reliable measurement, as well as nanometric accuracy, thanks to the higher resolution wavefront sensor technology. And you can see in little bit details as precise advantages. So that's it.
Thank you.
For a short presentation. Thank you for your attention.
Thank you, Marina. So do we have some questions here for this one slide presentation? Okay, if we have no question, you can still go back to us if you have any question regarding the speakers. So if you have a question about Marina's presentation, you can contact us. Thank you, Marina, very much.
Welcome.
So now we move on. We welcome Angelo Fasoli, the CTO of Tecnottica Consonni. It's a family company based close to Milan, which is specialized in the production of glass and plastic-made optical components, but not only. And we will learn more things during the presentation of Angelo. Angelo, you can share your screen and
okay. Thank you, Jeremy, and nice to meet you all. Okay, I'm going to share my screen. Okay. Can you see my presentation?
Yes.
Okay. So thanks again for inviting me here at this online event. My name is Angelo, and I work as a technical and sales manager for Tecnottica. Tecnottica is an optical manufacturing company which is based in Italy, very close to Milan, and it has now 65 years of activities. It was founded a long time ago in 1957, and I think it's one of the leading Italian companies which are involved in the optical market. What we are doing, we manufacture custom optical components and systems for several industrial applications, which with a unique philosophy, which is based on the concept, on the fact that we do not have any kind of product catalog. So we work only starting from custom specifications. These custom specifications may arrive from drawings that our customers can provide to us, or can arrive from an internal optomechanical design that we can handle. Our company is at the moment composed by 31st person, and the majority of them are focused in the production area. So definitely, as you can see also from the number written in the slide, we are a production-oriented company. We at the moment we serve several markets. It's sometimes also difficult to make a list of the markets we serve, simply because optics and photonics is all around us in everyday's activities, and it's very exciting to sometimes understand and be acknowledged about a specific application that the customer is using, is handling while using our optical components. Because many times I even don't know at the very beginning of the cooperation I have with the customer where he is finally going to use the optical components that we are manufacturing. And it's always exciting to understand and to discover how much our lives, our daily lives have to deal with the optical and photonics market. So basically, we work a lot for machine vision, just to tell you some names, astronomical application, biomedical and optoelectronics, security and defense, and rangefinder and sport optics. Specifically for rangefinders and sport optics, we follow some customers that work the field of natural observation, hunting or precision shooting, or other application, specifically like rifle scope, binoculars, spotting scopes, thermal imaging camera, or trail camera. Our production is basically subdivided in 5 macro areas. I like to point out that despite the medium to small dimensions of our company, I'm proud to say that we are fully independent in the handling of all these phases. So starting from the optical manufacturing, so we start from raw materials, and we can independently cut and round all the raw materials by ourselves. We have a very well-served mechanical shop where we are able to manufacture the tools that we need for making the polishing of the substrates, and as well we have a department for coating, cementing, and final assembly and testings of the optical components and system that we manufacture. This is very important to be independent in all these phases, especially in this very, very strange time when we all know how much customers are caring about delivery times, the fact to have raw materials in-house, to be able to reduce every step of the production manufacturing. And we all know that manufacturing of lenses of an optical systems, on the paper, theoretically it can be easy. No one knows unless you are not very involved in a production, in a manufacturing of an optical components, how many steps there are behind. And it's very important to be able to reduce all the timings that we have behind each steps. We have manufacturing capabilities with a good mix of CNC centers and traditional centers. For many years, optics was still considered, the optical manufacturing was still considered as an artisan thing. So the good thing is that now, thanks to CNC centers, making a lens is less an artisan thing. Now a computer can help you, but still for many reasons we still can be considered as artisans. So having a good mix of traditional and CNC centers can really help you to improve and speed up your production. So what we are manufacturing, as I said, we are all focused on customized products. So starting from single lenses, cemented lenses, prisms, optical filters, mirror, reticles, or plano optics. We start basically from dimension 1.5 millimeter up to 310 millimeters, and for plano optics up to 400 millimeters in the diagonal. Another good thing that we introduced in our production is the fact that we have a metrology department which is very well connected with our production. So we have 5 interferometers behind our polishing machines. So every step of the manufacturing processes, every polishing step is then followed by an accurate interferometrical test. This allows us to continuously control the process and to be able to really have a full understanding of what we are polishing and the quality level that we can keep. So some examples of our daily activities. So these photographs are specifically taken by courtesy of one of our customers, which name is Vapensmia, is located in Norway. So it's just to let you know which kind of product and services we can handle in our daily life. So starting from the manufacturing of single optical components, we can deal also with some optomechanical assembly. Everything is done in-house, and specifically I have some pictures here of some semi-finished products that are specifically related to rangefinders and sport optics, so today's topic. Thank you very much for your attention, and if you have any questions, I'm here for reply to you.
Thank you so much, Angelo, for the nice presentation. Maybe I start with the classic EPIC question.
Yes.
So we learned quite well what you can offer, but what you need from the community, from the photonics community of EPIC, for example.
Okay, so what we need from EPIC? It's a good question. So it's really exciting to be part of this community, because I believe that EPIC for a small to medium company like our ones can do really a lot. The main thing is to create good networking. We are all used to knowing new contacts, new people, traditionally at exhibitions, but now times are changing, and I believe that having the possibility to share our know-how, our expertise with such a huge network is really exciting. So what EPIC can do for us again is to make Tecnottica, to put Tecnottica in connection to some projects, to some startups, realities for which are developing new products based on optics and photonics. As I said before, optics and photonics is in all our daily lives. So I'm proud to say that it's an exciting world. where we are working. And again, I'm looking forward to meet the people with new ideas in mind in order to share our ability to make optical components with them.
Okay, maybe just to give a little more details. I saw quite large mirror or glass.
Yes.
Also, which is, let's say, your smallest optics that you manufacture, and which is the largest, just to give you an idea.
Yes.
Sorry, and then the second question is, which are the challenges during this production? So if there is also something that we can find there some EPIC member that you can support in your production challenges.
Okay, so first question. So we start from diameter 1.5 to millimeters, depending from the geometry of and the material, and the maximum diameter we can actually cover is around 310 millimeters. For giving you a reply on your second questions, so it's what we may need. Let me start from the fact that it is difficult for us to well train people inside our production capability. So what is good, and what I already started to do with EPIC, is to getting from EPIC itself, getting some how can I say, a good help in translating to our people in production some norms, some very specific tolerances, which are sometimes even difficult to optical designer to be understood, and how to translate them in a fluent way for our workers. So this is a topic that we already started with you, and I have already got some very nice information. And so I need some help in order to connect let me say, our production world to the optical designers world.
Okay. So I see that Christian Brock from Optocraft raised the hands. Christian, please.
Yeah, I wanted to. You showed the slide with the different markets. There were quite different markets on there, and the question is there one specific market that you think is most important, or that also in numbers for you is most important? And what do you think? How will this evolve? Where is it going, and which of these markets do you think will be relevant in the years to come?
Okay, that's really, thank you. That's really an interesting question. So if I have to give you a reply right now, I would say that definitely the market which I see is going to explode literally in the next years is the one linked to aerospace and satellite industry. So the reason that we decided to invest a lot in the last couple of years in CNC machineries for grinding and polishing of large lenses is due to the fact that we are experiencing a lot of requests coming from this kind of industry, which traditionally requests lenses with larger diameters. I mean, starting from 100 millimeters and above.
But usually only one, and one very difficult to manufacture and to measure.
Yes, it's really challenging usually, but you know, they allow you to increase your revenue. Let me say. So sometimes it's better. So what we manufacture basically small to medium volume production, high volume production. But it's you know, having to deal with this kind of large project, even if you have to manufacture only one piece, is it gives you a lot, let me say, of satisfaction afterwards, because you are involved in very specific projects, and usually with big companies or big universities, and it's very exciting.
Thank you.
You're welcome.
Thank you. I'm just looking if there is any other question.
Yeah,
from
I have a
people.
question, Antonio.
Yeah, please.
Just about your main challenges today. What is your main challenge of your?
Yes.
Yeah.
So the main challenge of our company is to connect the companies growing and the sustainability of its growing. Let me be more clear. We need to grow. You know, every year we try to find the new projects, new customers, new optical components to be manufactured. But at the same time, we have to be sustainable with the people that are working in our company. So to create a good environment around us and continue to think as a family company. I think that this is the main challenge, because as a family company, we can guarantee a lot of flexibility to our customer. Sometimes flexibility can slow you down or not, but we like to serve different markets, to be involved in different projects, and you know, it's always difficult to maintain a good balance behind all of these tasks.
Thank you.
Okay, so I'm just checking. I just checked if there is any question from YouTube. So we have also people following us from YouTube. So big greetings to the YouTube tribe. And if there is nobody else that would like to make some other question, I will proceed with the next speaker, Christian Bloch from Optograph. So the attention and the floor is to you.
Thank you. Then I'll share my screen. Oh, here we go. Yes, I'll give a short presentation on Wavefront metrology for optics testing. So basically, what we do with Optograph, we build Chuck Hartman Wavefront sensors, subsystems and modules, like you can see in the middle of the slide, and turnkey instruments. And we are also a company with roughly 30 people. We were founded in 2001, located in Germany. My colleagues work in software and mechanical engineering. There are many different application engineers. We're doing our sales in Europe and in the US, and we're working with distributing partners in Asia and in Israel. And yeah, since 2018, we have a partnership with Micro Epsilon, which is a company who is also located here in southern Germany. They have roughly 1,000 employees, mainly also working in Germany, and they are manufacturing sensors for displacement measurement and for shape measurement. So flexible optics testing and measurement of sport optics. So for this market, basically, we offer the RL module, which can be used for the double pass testing, as shown on the image on the left-hand side. And I will share some more details on that on the next slides. It can also be used for the reflected light measurement of optical surfaces like mirrors, or also spherical mirrors, concave, convex mirrors. So you can use this module for measurement also of objective lenses, camera lenses, or also smaller lenses like they are used in your smartphone and similar systems. So here's an example of a measurement where basically you can see on the top right here the RL module with the wavefront sensor. This blue box, it will output a collimated beam, which we will send through through one channel of the binocular, as it's sketched here. then there's the planar mirror. The light is reflected and passes through the sample under test a second time, and then is imaged by some relay optics towards the wavefront sensor. And in this way, we measure the transmitted wavefront. And you see here the wavefront where we subtract tilt and defocus. And in this case, we measure the low-cost binocular of the which has a small entrance pupil of 4 millimeter. And in the wavefront, you can see that there are, the RMS value is 0.27, so you have quite some amount of coma in there. And the MTF, which is calculated from this wavefront, you can also see that there the transmission behavior is not so well of this. It's a low-cost binocular. We also checked the high-quality binocular. And in comparison, when you can see that the transmitted wavefront has much lower aberrations. Still, there is a bit of aberration present, and you can see in the false color plot and also in the Zernike analysis. But the RMS value of this wavefront is much smaller, and also the MTF looks much nicer than for the low quality binocular, which is basically what you would expect. Yeah. So you can see here the difference. So this is an example for a double pass test, and a nice thing about the Jacques-Hartmann wavefront sensor is that you basically can use it also for alignment purposes, since it gives you a frame rate of about 10 Hertz, for example. So that's just enough for an operator to do online alignments if necessary. So we can expand this if we are now not looking only at a single channel, like for example for a rifle scope or a spotting scope, or just a single channel test of a binocular, but we can basically add a big telescope in front of our module, and then we can do a simultaneous measurement of both channels of a binocular. We need some dedicated graphical user interface then, which is shown here below. So basically, you get the results for the left channel and for the right channel. And based on that, you would also be able to analyze if your binocular actually is looking if the two channels are misaligned, one with respect to the other. So you would get that information. And of course, the overall quality of each channel. And right, so the nice thing about such setups is that you can very well reference the system. So you basically remove your sample, you take a reference measurement of the empty system, and that's it basically. Then you have taken into account all the static measurement errors. So one more slide on the measurement of objective lenses. So this would be the configuration when you want to test in a double pass test. You want to measure an objective lens. Instead of a planar mirror, now we have a reference mirror, and a concave reference mirror. And this is due to the fact that the objective lens will create an intermediate focus, and we just have to catch the light that has moved through the focus and then is reflected at the spherical mirror. It will go back the same way it came, all those rays, and in that way we can realize the double pass test, which we usually do for microscope objective lenses or smartphone lenses, camera lenses, these type of objective lenses. Okay, so that's basically all the technical information I wanted to share. What can we do for you EPIC members? We can, of course, share our expertise in optics testing, and we will be able to deliver smart solutions for optics testing. Like, as I mentioned, the Bayer Jacques-Hartmann wavefront sensor head modules, which you can integrate into your test benches or production lines, and also turnkey solutions. And what we are looking at, basically, as always, we're looking for interesting new projects. That's clear, challenging, but we are also looking at where is it going? The current advances in technology, So what challenges do you see in your optics markets? And maybe there are solutions that we can develop. In addition, what currently our topics is like off-axis parabolic mirrors with high quality. We do not usually get those at the standard providers. Small meniscus lenses and planar precision cuvettes. These are optics that that we would be also interested in. And yeah, in general, challenges is, as mentioned before, the current supply chain issue. And one more challenge would be maybe the measurement of large freeform optics. So this is just a remark to all the optics manufacturers who come up with new crazy designs for large head-up displays and all these stuff. These head-up displays need to be measured, and as these optics are measured also with a they are manufactured in not only in single pieces, but there is a higher quantity. They need to be measured in a quick and fast way, and this is a challenge that we are working at. Basically, with our technology, we can do very quick and fast measurements, single shots measurements. But if the freeform is too freeform, then we are getting at some limits there too. And then actually, what remains for the manufacturer is again the scanning point by point of such freeform optics, which is time consuming. Okay, well, I'd like to thank you for your attention, and I would be happy if there's one or the other question. Thank you.
Thank you so much, Christian. So it's very impressive, and I'm really curious. Was really curious about the freeform, because yeah, this is probably the challenge for the future. Is mainly related to large freeform or also to small to micro freeform optics. Your challenge.
Now, basically, all freeform optics can be challenging. They must have to be challenging from a metrology point of view. But the larger and the more freeform, the more challenging. Basically, it is. Yeah. Mm-hmm.
So I see that also we have Jonas from Vilans, UPMT that raised the hands, and then also Tracy Vanek. So please, Jonas, go first, and then we go to Tracy.
Well, hello everybody. Sorry, I'm Mark, and I'm the father of Jonas, so I'm disappointing you. Jonas is not there at the moment, but
okay. Because okay, I see the name. Sorry, I see the name.
Yeah, sorry. A question to Christian. A very interesting talk. I was wondering if you were using lens arrays to make your patterns of Schack-Hartmann. I'm not an optical engineer, but I'm just wondering how that works. Can you explain this?
The Schack-Hartmann wavefront sensor uses a micro lens array. Basically, you have a CMOS camera, and in front we put a micro lens array, and in principle that's all already. Yeah, this will give you the Schack-Hartmann wavefront sensor, and the challenge in doing a good Schack-Hartmann sensor is in how you do this, how you calibrate this, and what kind of components you use in order to get this. Yeah, so the micro lens arrays typically have 100 times 100 micro lenses or 200 times 200 micro lenses. So this is the order of magnitude that we're looking at here. Mm-hmm.
Do you manufacture these in-house, or do you buy these?
Nowadays we buy these.
Okay, and can you tell me in what materials they are made of? Or is this plastic or is this glass?
That's fused silica.
Fused silica. Okay.
Glass.
So Mark, if it's okay,
Thank you.
I will give the floor to Tracy Vanek. Maybe just a short introduction. Tracy is our great colleague looking for the market report. So it's really our eyes on the old technology. So Tracy, please, the floor is yours. But you are muted, Tracy.
There. Thank you, Antonio. So Christian, very interesting presentation, but I had a question. When you talk about testing, so you do testing, do people send you their lenses for testing? But then you also mentioned that you have systems that you can do, testing on site. So how does this work? Do they send you the lenses? Can you sell your systems for individual sites?
Oh, we sell our systems, so that's our main business. It's the sales of metrology to manufacturers of optics. So we develop and we sell these systems, from the Jacques-Hartmann wavefront sensor as a tool which is used in the lab, or also which can be integrated into production machines for maybe an online monitoring during the manufacturing process. So this is just the camera, so to say, the Jacques-Hartmann wavefront sensor. And then there are modules and also the turnkey systems which we develop for dedicated purposes, like the testing of a camera objective lens. Yeah, there are companies like maybe Leica Camera who use our who buy our instruments and then use them during the manufacturing or for the quality control of their products.
That's very impressive. What about for educational systems? Do you ever do testing of one-off lenses or in-house, or is it mostly the turnkey systems that you sell?
We also do tests as a service, so to say, with the systems we have here. Mostly in terms of feasibility studies, like this. Mm-hmm.
Wonderful. Thank you so much.
You're welcome.
So this topic is raising the curiosity. So I see Andres Cifuentes from company Hase raised the hands. Please, Andres.
Hi, everyone. Thanks for the presentation, Christian. A question, I don't know, maybe if I missed it in the presentation, but is there any plans in future development to go to other wavelength ranges outside of the silicon or the CMOS type of sensors?
Yeah. So for the shortwave infrared, actually we do have a product also for the UV down to 193. And so far we do not have solutions for the midwave or the long wave infrared. But from this NIR to shortwave infrared, so that would be based on an indium gallium arsenide camera, which we can do up to 1700 nanometers.
Okay. And is your existing software package compatible with these other wavelength sensors?
Yes.
Mm-hmm. All right. Thank you.
Okay. So I don't see any other question for the moment. Please feel free, if you have also question later, to contact Jérémy or me, and we are really happy and proud to make the connection and the introduction among us. So I will proceed with the next presentation. We will have, oh my God, I don't read very well the name, but we have Pixel-sur-Mer. We have Romain Gouillard. It's ready. I see that he's already working on it. Here we will really take a breath of sea. The floor is yours, Romain.
It's okay. Do you hear me?
Yes, perfect.
Okay. I'm glad to be with you today for this meeting. And today I'm going to talk about structural health monitoring on a racing on a racing setting boat by using fiber optic technologies. Okay, my presentation will be into three parts. I will introduce my organization, my company, Pixel Sommer. And after, I will explain you what we do with fiber optic sensors. And at the end, I will talk about what we can offer and what we need. Pixel Sommer is a company was founded in 2008. We are 17 co-workers in your company at the moment. We are settled in France, in Brittany, in Lorient. Lorient, it's I think Lorient is a city in France where you can find the most significant number of racing selling team. And our office are located close to the harbor, just close to the facility of our customer. We don't work only with a racing selling team, but most of our customer are in this field, and sometimes even frequently we can go abroad to do some installation or service. Pixel Sommer consists of 3 business units. The first one is the design office. We design and we product and we design and we manufacture our own products and software. Just here I put 3 of them. It's a kind of flagship products. The first one is Exocet Blue. It's a kind of black box like on the plane. We can record data and we can synchronize this data together. Because on the boat we need to know plenty of parameters essential for the safety of the crew and essential for the performance. And that's why we can record with only one box and we can synchronize. And it's very, very practical because it's easy to get a value, it's easy to get data, but it's more complicated to find the context and why we get that. The second one is Exocet Silver. It's Pilot. It's to help the skipper to sail efficiently through the ocean. The skipper give an instruction, for instance, a specific angle between the wind direction and the direction of the boat, and automatically the system meet acoustic with the instruction. And the last one is the Exocet Gold. It's a flight controller. Now a modern racing boat can fly over the water, and it's sometimes it's complicated to have a stable flight because if the sea state change suddenly, we have to do some stuff on the boat to keep the boat flying, and that's why we need sometimes to have some system to reach this purpose. The second business unit is onboard system integration, because on the boat there is a lot of device to pick up different parameters like wind direction, spin measures. All these parameters is essential to sail efficiently and is essential for safety. That's why we have a few radar antenna to locate the boat on the surface of the Earth, or some antenna to communicate with the outer world. And that's why all these equipment need electricity supply. That's why we have to install a battery. We have to wire to connect all systems together, and we have to configure the system with the computer on board. Yeah. And the third business unit is structure is monitoring. It's the business unit in which I work, and why we put some sensors on the boat. It's for safety purpose and for the performance. Why we well, what is why it's important to have to measure strain on the boat? I take one example. It's the Vendée Globe. It's the most prestigious race in IMOCA class. It's a kind of a boat. You can see just a picture on the below at the bottom of the screen. It's the race around the world, and it lasts roughly 70 days. And on board, the skipper is alone. There are nobody with him to help him. And in the middle of the ocean, sometimes the sea is quite agitated. The sea state is rough, and the boat needs to sail very quickly because it's a race, and the goal is to win. That's why sometimes the structure is overloaded, and you can have some damage which can appear. And moreover, on the boat, the skipper is occupied because sometimes he needs to he has to choose his strategy. He has to do some maneuver on board, or sometimes he has to have a rest because he is a human, and that's why it's essential to assist him to put into place a structured health monitoring system with alarm. We can define an alarm about what is the maximum strain we can accept, and if the strain is higher, you can warn the crew. Why we use optical fiber? Because it's highly compact. The diameter is roughly 250 micrometers. That's why it's easily integrable and lightweight. It's very essential to have an optical fiber inside the structure, because if it's stick out, the risk is to break it by contact. We can put the optical fiber inside the composite material, which inside the material of the structure. Most of the time it's a composite material, or on the surface at the bottom of the graph. It's suitable for marine environments because optical fiber is made of fused silica glass, and that's why we don't have any corrosion phenomena. It's very high accurate and high precision technology. We can measure strain, very weak strain. It's for instance, if you take a bar and you put this bar under rotation, you stretch the bar. The longer of the bar is higher, and strain is the ratio between the lightening and the initial length of the bar. And with the optical fiber, we can measure 10 micrometers lightening of 1 meter long bar. And it's possible to measure strain with high frequency. It's useful for our application. Just to explain how we implement the optical fiber, for this example, I take IMOCA boat. It's a monohull, and this boat has several elements. The first one is the foil. It's like a wing for airplane. It's the element which enables the boat to fly over the water. And it's for IMOCA, it's the element which more frequently equipped with optical fiber. Then, so we bond the optical fiber on the surface of the foil, and the optical fiber containing several sensors. These sensors are FBG, a fiber by grating. This grating is similar to a series of mirror with a weak reflectivity. And when we launch some light inside the optical fiber, the light propagate and reach the grating. The light reaches the first mirror, and so a small amount of light is reflected back. So after the transmitted light reaches the second mirror, the same phenomena happen, and so globally the fiber by grating works like a mirror, the same mirror inside your bathroom, but the difference is this mirror reflects only a narrow wavelength band, excuse me, and this band is centered at a specific wavelength, which is a Bragg wavelength. And the value of these Bragg wavelengths depend on the pitch, the distance between the mirrors. And when the structure gets strained, when the structure is deformed, the optical fiber is deformed as well, because it's bonded on the structure, and the distance between the mirror change, and we get a wavelength shifting, and by using a calibration law, we can deduce the strain of the structure. It's important to note the function 1 and the function 2 is made with only one device, which is an optical interrogator. And you can put several sensors on the structure by doing wavelength division multiplexing. We can allocate one peak for one sensor, and the different wavelengths is got by using different specificity during the manufacture process of the fiber bar grating. Some picture of one installation of optical fiber on the foil and during the manufacture process, and one picture of the foil which was broken during sailing. The strain is pretty high on these elements. It's very crucial to know the strain. Other installation on the bottom at the bottom of the hull, because when the wave hits the hull, we can have some crack initiation inside the hull. It's very essential to not hit. And last application in the installation of the mast for two reasons. It's essential to know the compression load inside the mast, because sometimes we can have some demasting because the force apply on the sail was too significant. And the other purpose is for optimization, because by changing the curvature of the mast, you can adapt, you can adjust the shape of the sail, and then you can optimize how the say work for a specific wind condition. A few applications. We work on different class of boats for the America's Cup, for the class Ultime. It's the big trimaran. Scorpius 125 and IMOCA. But we work as well for other fields like aeronautics or industry. Then I think you understood we don't produce any optical components, but we need to have some optical components for our installation, especially we can sell because we are distributor, but we don't produce. But we need some optical components, especially optical interrogator. We use a very reliable and very accurate interrogator. But for some application, the interrogator is sometimes too heavy, or the electricity consumption is too high, and that's why we try to find a kind of alternative to make this technology more onboarding. I don't know, especially on the light structure. We are looking for as well a few FBG array supplier, especially when the fiber by grating is written on the tower, on the drone tower, because for this kind of application, the optical fiber is stronger, and the cost is lower. We need connectors, specific connectors for specific application, especially for application with high temperature, 120 degrees, or a connector or watertight connector. We have some of them, and it's a good one, but we need to have more components to propose to our customer, and other optical equipment as well, splitter and switch. Yeah, thanks for your attention.
Thank you so much, Romain, for this great presentation. Really, it was, I'm really speechless because I am in love with photonics, but more than photonics, I love C. And, really, I will come to visit you in Lorient.
If you want,
I provide that
yeah,
I will come. I will come because this is a really great presentation. This is really, I see that already Tracy has some question, and then I will make my question. So Tracy, please go ahead.
Oh, thank you so much, Antonio. So Romain, this was excellent. This was so interesting. I was expecting stress measurements to detect aging. I was expecting something that would be more static, but instead you have real-time measurements, and for a variety of different things. I mean, to be able to detect the shroud load, and this is just amazing. So so what I was really surprised at is that this is real-time monitoring. Is there, what is the power that is required in order to do this? Does that ever become an issue on the craft, or?
The electricity power for the system? Normally, the integrator need 30 watts electricity power. It's not a lot. It's like a computer, a small computer. But I know sometimes on the market there are a few interrogators with 10 watts. 10 watts. It's quite small. It's interesting, but I tested some of them, and the result of the test was not
good. Yeah.
was not good. Yeah.
And also your aeronautic applications. Are you looking for more aeronautic applications, or are you seeing much uptake here?
Yeah, we want to have more application in aeronautic. We at the moment we work with 2 companies in this field, and we speak with a 3rd company. But if it's possible to offer our service for other company in aeronautics, it will be very nice.
Thank you so much. Really appreciated this.
You're welcome.
I see that there is for the moment. Okay, I see Marina from Photonics raise the hands. Marina, please.
I have a question about you choose the wavefront sensor. Sorry, the fiber sensor, the break rating, but there is like alternative like Fabry-Perot. Is it particularly criteria because they also support harsh condition?
Yeah.
And is it was your decision because you say you're not like optical part? So on this,
it's a good question. There are several technologies, but there are several fiber optic sensors technologies, but it depends of the kind of the application. Usually in civil engineering, we will use we use optical fiber based on scattering inside the optical fiber. You can get a strain continuously along with the optical fiber, but the main there are 2 disadvantages. The first one is the location of the measure is not really accurate, unless for Rayleigh scattering, but it's more expensive. And the second disadvantage is the frequency of the recording. We need to have at least 10 measures per second, and for the technology based on scattering phenomena, usually we can get as a measure once a second or 2 a second. It's a limit. Yeah.
So okay, it's like criteria of performance efficiency.
Yeah, right. Yeah.
I see.
We have to choose.
Okay, thank you.
Thank you.
Thank you so much. And Xavier, bonjour, from company MicroLED also raised the hands. Please, Xavier.
Yes, Romain, quick question. All this stress data, what do you do with it? It's like 10 hertz of data. Do you feed that to a computer? Do you feed that to a display? How is it used by the crew?
Okay. There are two applications with the data. The first one is to set alarm and to visualize in a real time the measure. Then just at the beginning of my presentation, I show you Exocet Blue, the black box, and there is a kind of interface where you can when you can set a few dashboard and you can visualize in real time the data. And if the stress is too high during sailing, there are some alarm which can ring to warn the crew. And otherwise, the data are recorded and synchronized with other data on board, like heel angle and speed of wind and so on. And after the team can analyze this data and can make some conclusion. Sometimes, if you note the stress was not really high, and you are very far from the limit. For the next generation of the foil, you can decide to make the structure lighter, and like this you can save weight. It's a very essential parameter for performance.
Thank you.
Xavier, I have to ask you, do you think that it could be possible to use your technology in
Yeah, that's exactly what I had in mind. I think I'll give a ring to Romain after the meeting.
Yeah, great. Perfect.
Okay, that's the epic spirit, and I will say that your presentation is fantastic, and I would like to offer my full support of myself and all my colleagues, starting from Jérémy. We will find a lot of solutions for you, Romain, and
okay.
We have a lot of ideas. I just invite you in 2 weeks. We will speak about fiber optic sensing in medical field. It looks so strange, but it's exactly the same technology. And there is a company showing that they can see the shape, the modification of the shape. So I think that it's really far from your target markets, but it's the same technology. So maybe,
the goal is similar. Yeah.
So it's a good example also of a cross-fertilization among the EPIC environment.
Okay.
And okay, just another example. I'm really a pleasure to introduce Jessica Van Heck.
Oh, sorry, Antonio. I have just a question to just a technical question about the technology. So you measure mainly in one dimension, but do you? It's in 2 dimension. Should it be possible for you to measure in 2 dimension, or should it be interesting for your application?
Yeah, very interesting, because with fiber bright graphene, you can get the strain at a specific location of the structure, but it's more complicated to know how globally the structure is deformed, and you can from these located you can from these local measurements to get the global deform of the structure, but sometimes you need to use a very complicated finite element model, and you can do 3-dimensional sensing on the mast, because mast is a very simple structure. It's a kind of tube, but on the foil it's more complicated, and that's why it could be interesting to use other kind of optical fiber. At the moment, we use a single mode optical fiber with a sensor inside, but if we can use a multi-core optical fiber, it will be easier to measure strain in 2 dimension, and but it's an interesting application, and I think our customer will be very happy and very glad to know how the structure is deformed in 2 dimensions.
Okay, thanks. And another question about your more global, but about your main challenge. Technical challenge. How do you see the evolution of your work in terms of maybe precision of the measure, or maybe about new technologies, or?
Regarding the precision, it will be difficult to make better. I think, but I think for the future, it will be very nice to be able to see the structure, how the structure is deformed during selling but in real time. And I think it will be very helpful for our customer, because it help them to optimize their performance.
Great. Okay, thank you very much. Okay, so yeah, now we can move on, and the next presentation is about a European project, pilot line about freeform optics, and we welcome Jessica Van Eyck for this presentation. Jessica.
Yes, thank you. I share my screen. Presentation mode. So yes, Fabulous is the.
So Jessica, can you just full screen? Perfect.
Took a little time. No, so yes, Fabulous is a European project. It's a European pilot line and one-stop shop for the manufacturing of freeform micro-optics. It's also a legal entity. And to explain a little bit more quickly about freeform micro-optics, this means micro-optical components without any symmetry constraints. And so this is then enabling a lot of new and miniaturized solutions that can also be used for sport optics. And we see already a gain increase from the industry. And so if we are looking specifically at the applications for sport equipment, so of course they can benefit from integrating sensors, and then the micro-optic freeform micro-optical components can help with the efficiency increase for solar cells, for decorative design, for increased aerodynamics, or for integrated displays. So this is also one of the use cases that we've been working on within Fabulous. Micro OLED is here. They will say something about integrated displays, which micro-optics, freeform micro-optics can then help with the brightness enhancements. And then, so what can we do for you? So if we are looking at the users of the components, then we offer the manufacturing services. So really as a one-stop shop, we have partners that can do design, origination, tooling, replication, quality control, integration. So really we have all the partners on board to help with these services, and then we can do the prototyping, piloting up to the large volume production. And right now, as Jérémy already mentioned a little bit earlier in the meeting, there are some funding opportunities now through the open call. So that means that there is money available for companies looking to integrate freeform micro-optical components into their system. So this could be very interesting for sport equipment, but of course also it's also open for any other industry. And so this is what we can do for the users. What we can do for the technology providers is, so we are, as an association, also creating a big network and community. So we encourage all of the suppliers within the micro-optics community to become part of the value chain and join the ecosystem that we have set up. And so this consists of an organization, the registry, a marketplace in the community. Through the marketplace, any company can also put in their offerings, which means that it could be also a lead generation tool. So this is what we do for you, for both groups. And then what you can do for us is then, well, yeah, if you're an end user, then please apply for our services. And if you are a technology provider, then join our ecosystem. And then, yeah, so contact us, follow us, and, become fabulous. So here are the details. The front office is run by myself, and Tom Offenmans is technical coordinator. And yeah, I look forward to talking to you. Thank you.
Thank you very much, Jessica. So yes, if you're interested, do not hesitate to contact Jessica or contact Antonio or me for more information, and we could put you in contact with Jessica with Fabulous. So
thank you so much.
Yeah. So what a better introduction for the next speaker with actually a use case of the Fabulous pilot line. So Xavier Bonjour from Micro OLED is going to present us Active Look. So Xavier, you can the floor is yours. You can begin.
Okay. Do you see the presentation? Is it?
Yes.
Okay.
Perfect.
So yeah, the subject I wanted to introduce is the notion of light augmented reality, and we have a technology for that, which we call Active Look. But before that, a few words of introduction on MicroLED, so which is the company that makes this this technology. So MicroLED, we do micro OLED displays. Typical applications, of course, it's augmented reality, virtual reality. We do a lot of things in the, it's anything which relates to the near the eye optics. So vision enhancement, whether it's thermal vision, night vision, anything that has a scope in it. And also we decided to enter the market of smart glasses, and that's the subject of this discussion. Yeah, MicroLED, it's more than 100 people, slightly more than 20 million revenue, and it's I wanted to add that. Light or Active Look. So we decided that augmented reality, it's a big market, many use cases, and we thought there was a gap in this market for use case which is typically compatible with motion. You know, the use case related to gaming, to maintenance, to productivity increase, but we believe there is a use case which relates to having visual information when you are in the action, when you move, and also in terms of architecture, we think that it's not necessarily a good idea to put all the computing power in the glasses, because that's something which is very difficult to do in terms of weight and power consumption. And we decided to propose a rather different approach, which is to provide a companion technology to other devices. And that's what we call, well, that typically could be a new market segment in augmented reality. At least that's our vision, and that's what I want to explain. Now, what are the challenges to do that? I think the biggest challenge the technology has to solve, it's the weight. You need, for glasses, especially when you want to move, they need to be very light, probably below 40 grams. Another thing you have to achieve is good design. Smart glasses, it's not a technology market. As soon as you talk about glasses, it's a fashion market. So you need to be able to provide good designs. Otherwise, it's unlikely you are going to be successful. Now, a bit of engineering, you need to provide autonomy. The smart glasses to be used, they need to be able to be used for quite some time, definitely more than 4 hours, and we believe that 8 hours is the lower limit. That's actually correspond to the time of a shift in the industry. Another thing you have to bear in mind, and which could be pretty difficult to achieve, it's also content visibility. You need to be able, especially when you are in, when you have some activity, it usually happens outdoor, and you need to be able to be visible during very bright and sunny light condition. Something we discovered as well, the information you put in the field of view, you cannot block the central field of view, and you cannot block the peripheral vision, because that's where the danger comes from. So you need to accommodate with these constraints. And last but not least, you need to be able to provide interesting content. And that's why, Romain, would like to talk to you, because anything which is real-time information has a lot of value to be to be displayed visually in these glasses. And we have other examples which I could speak about, but your example, providing information to the crew of a racing boat, I think there is a use case. So after several years of development, that's the technology module we propose to achieve that. We include everything in a module which and the technology is called ActiveLook. It's a set of components and also software, firmware. The whole package, it's about 6 grams. So it uses an optical system. So it's a high precision microprojector, which uses the freeform lens. So it could be, and of course we have the display, and I'll come back to that later on. We have the electronics. One of the unique specificity of this technology is that we don't want to put a mobile phone in glasses. We only want to connect to either mobile phone or to any smart device, really. So it could be a smartphone, but more interestingly, it could be also a smartwatch, especially for sports activity. So the electronic modules, what it does the Bluetooth low energy connection with the device. It does the driving of the display, and it runs all the firmware that does the display content. We've also added 2 sensors. One is for the ambient light. You need to be able to adjust the brightness of the display to the outside environment, of course, whether it's night or a sunny day. And we have also introduced a gesture sensor, or rather a presence sensor, which detects if you wave your hand in front of the glasses, it's going to be detected, and you can do something with that. You could change your screen. I mean, the application can use it. And of course, we have a battery. Autonomy is at least 12 hours. It could be more in some conditions. And it's not part of the 6 grams, but the lenses in this solution are a bit specific. The shape of it, the type of coatings we put, because we include the lens in as a component of the optical system. A few words on the business model. So we have this ActiveLook module. The business model is that we sell the technology to the eyewear industry. So our customers are glasses manufacturer. And ActiveLook is just an ingredient brand. Powered by ActiveLook, think of it as Intel Inside. That's the same type of business model. On the other side of the equation, we provide an API, which is completely open source and free, so that anybody in an ecosystem can create content or develop applications or make device compatible with the ActiveLook technology. And when they do that, you can access the display of the glasses the same way you send audio to your AirPods. You know, it's just completely open. A few words on the technology we are looking at here. So currently we use, it's just what I would call a standard head-up display, but of course the big challenge for us is to shrink as much as we can of this. And the other challenge, because these are smart glasses, we need to be able to provide prescription in the optical system. So the shrinking, we are working on a solution, and that's why we are part of the Fabulous project. But we are also working on a solution which is I would call it waveguide based, so that we can include or propose to our customers the notion of prescription correction. So last but not least, this is, well, there are 2 reasons why we can do what we do. The first one is we chose to go for a companion display architecture, rather than a mobile phone smart glasses. So that helps. But the other, I would say, disruptive feature is that we have designed a display specifically for this application, and it's a very, very low power display. It's only 1 milliwatt, which is at least one order of magnitude lower than what the rest of the industry can do, and that's why we can have a very small battery and save on the electronics and save. Low power means low weight as well, and so we have designed this display specifically for this new segment of light augmented reality applications. Well, I guess, yeah, I'm done with the presentation of the technology, and let's have time for questions.
Yeah, thank you very much, Xavier. Interesting. So, yeah, okay, we have a question from Vidlands, the PMT, Mark Vidlands' father. Yeah, you are muted. Huh?
Okay, so yeah, hello, Xavier. Very, very, very interesting technology that you are developing, and I think it's a very good idea to just do the communication on the smartphone side or the watch side. I think that's really very, very intelligent to bring the cost down of these glasses, and also to have a connection with without getting obsolete on that technology too early. I'm just questioning, will you also over time integrate cameras in your glasses, you think?
It's going to be difficult. The main reason for that is the camera. It has a lot of bandwidth demand. Mm-hmm. If you want to broadcast video to a device. That means big batteries. That means so it's going to be technically it's going to be difficult. Light smart glasses, it's not compatible with video. It's hard, at least not yet. And the other thing is it's more a vision thing. We'd rather provide superpower to our users rather than what other people do with a camera. It's also a way to profile you better. And we believe that's the market for smart glasses should be more driven by superpowers than by advertising.
Yes, but suppose I'm walking somewhere, I'm looking after a restaurant, and I would imagine this is one of the let's say the straightforward applications is to show me where to walk with that. Is that something that you can do with your glasses?
Yes, absolutely. We have navigation. You have it's the type of display you see. It's a head-up display. So you can, and we have partners which provide navigation solutions where you have the turn-by-turn navigation. You have we even have map-based navigation, which is feasible. The display is 300 by 256 pixels. It has 16 gray levels, so you can do a lot with this type of display in terms of visual information. But you have to bear in mind that when you move, your brain, it's very difficult for your brain to absorb additional information. So you need to be very, that's something people don't necessarily realize. When they sit, they can have a lot of information, like in Iron Man. But when you move, that's a different story. And like watching video when you move, your brain cannot cope. Either you stop and you watch the video, or you ignore the video. So we are not, that's not something where we are going to, at least in the short term, we don't want to focus there.
Okay, very interesting. Thank you.
Thank you for the question. We have another question from Christian Brock, Optocraft. Christian.
Yeah, so you mentioned the prescription value and the vision correction. Is this something that you do, or was that your hint to your cooperation with lens manufacturers?
That would be the later, because what we do is we provide the core of the technology, which is the display, the electronics. We offer one solution, which is the one I introduced, which we do ourselves. But of course, if we want to go into waveguides, we are not going to do that. We are going to partner with somebody.
And would you expect that this technology then will be available for all kinds of glasses, from high power, low power, for all kind of prescription values? Also, maybe progressive.
It depends on the. Ideally, yes, but of course there will be choices to do, and we have to. It will depend on the solution we consider.
Mm-hmm. There will definitely be a challenge for the manufacturers of the glasses of the lenses to integrate that, and that's
well, currently we have a solution. It's called contact lens, so that's
okay.
I mean, if people are really motivated, they can always use contact lens. So and the other something, the fact that we project the image at the infinite, which more than 1.5 meters, people with presbyopia, they have no problem with the content. Like, I cannot see my watch, but I can read pretty much everything in the glasses. So actually, customers or end users which are 45 and above, they love our product. They love our technology.
Yeah, thank you.
Thank you, Christian. Do we have other questions from the participants? Maybe Xavier, you could show us the prototype.
Well, we do have. This product is on the market, but we're also working on a next generation platform for our customers, and that's typically the kind of that's the one you have in the pictures. So it's a real product, and this one, I guess, this one will be on the market in a few months, if not weeks.
Okay, great. Thank you very much. So if we have no more question, maybe we can present you the summary slide. We used to do this kind of summary slide to close the discussion, and after we will continue the discussion after this. You can stay if you want. We close only the live on YouTube. So yeah, it was really interesting to hear your presentation. Thank you very much to our speakers. What we can keep as information is that, for example, for the rangefinder, we want to measure higher ranges. So to do this, we need more power, but it's not as simple. We have also to use maybe a new type of doped glasses, as SCHOTT Gernot Weber showed us sooner in this presentation. About also optical component fabrication, we have information that the market will explode in future, but the main challenge for this is to improve sustainability and flexibility to answer the high demand of the customers. From the optical metrology part, okay, a big challenge is for free-form optics measurement. We have seen that for larger optics, it's more challenging actually. So there will be a lot of opportunity on this market for the metrology part. It's really interesting. And about application for optical fiber sensing for sales races, what I have information is that we in near future, we would like to measure the structural deformation in real time. It's something that you really want to do. And about air glasses, from the presentation of that, the shrinking and prescription is something that is really challenging for you. And yeah, it's something that you have to reach for mass adoption by the consumer market. So yeah, again, if you want to contact one of our speakers, ask Antonio or me. You have our email address, and we will put you in contact with our speakers. Of course, I would like to also to thank all of our speakers today for the great presentation, really interesting with this subject, optics in sports. It was a pleasure for us to prepare this event with all of you. And now we are going to close the live on YouTube, but you can still stay here to discuss with the participants and also with the speakers, of course. So thank you very much to all.